Released in 2005, this little box here is not a network-attached storage, but a micro SAN. Using technology licensed by Cedra and Dataplow, the NetGear SC101 brought IP-based block storage into consumer homes. A neat idea, done wrong? Let's talk about legacy network technology. I'm the Vintage Collector and these are my stories. In 2005, US-based NetGear made their first attempt at the storage market. Though we're not talking about NetGear's Ready NAS series, which came to NetGear only by 2007 after acquiring Infront Technologies. But 2 years prior, NetGear brought the Storage Central SC101, claiming to bring you easy to set up shareable network storage with the simplicity of your C:* drive. And it did that using IP-SAN technology, which gave you block-level storage, but more on that again in a moment. According to this small review in PC World magazine in December 2005, SC101's initial price was around $130. The Storage Central SC101 was a cute little box, offering just enough room to accommodate two 3.5-inch IDE hard drives, which were not included. Just pay attention when equipping those disks that they must not be configured as an IDE master and slave, but for cable select mode. In the end, it was entirely up to you how much capacity you stuff into this box, aiming for unlimited upgradability as per NetGear's claims.
At least up to the maximum hard disk capacity available at the time.
Or by simply putting more than one SC101 into the network. Besides that, the box didn't offer a lot of buzz, as it had only a 100 megabits Ethernet port and the power connector, some status LEDs, but no distinct on-off button on its own. And, as mentioned before, Storage Central was built around IP-SAN technology. Now, what does that mean? In my last episode, I talked about Windows Home Server. Windows Home Server running on an appliance server was similar to competing products by QNAP or Synology, but also later years NetGear Ready NAS series falling into the category of Network Attached Storages, or NAS for short. A NAS, like any traditional file server, exposes various file sharing protocols, be it Server Message Block, Apple File Sharing Protocol, or the Network File System, just to name a few. On your client machines, you'd then simply map those file-level shares to a network drive in the DOS Windows world or a mount point in the Unix world. And this is very universal to use, as pretty much all operating systems out there support either of those sharing protocols. Not unlike the Storage Central 101, which uses a SAN technology. SAN is short for a Storage Area Network, and typically those are used in large-scale enterprise networks. Usually SANs consist of huge disk storage arrays, which are connected to servers through dedicated fiber-based networks using specialized fiber channel host bus adapters. These storage arrays are then normally split into logical units, often referred to as LUNs, which makes them available to specific machines, which then sees the LUN like a local hard drive. As opposed to NAS file shares, these LUNs cannot easily be shared between different machines unless a special cluster file system is used. And while 2 decades ago, SANs have been evolving into Ethernet and IP-based networks, with iSCSI eventually becoming a feasible standard technology for block device attachments, the typical NAS appliances also started to support iSCSI at some point. So the question is whether the Storage Central 101 is an iSCSI SAN product. And apparently it isn't. Instead, NetGear went to license IP-SAN technology by Cedra Systems. So let's have a look at how this one worked. After you have installed the hard drives into the SC101, it doesn't need much more than plugging the Ethernet cable and applying power. Now, on the client side, this product originates from a time where 64-bit operating systems were not the default yet, and originally it was meant for Windows 2000 and XP only. No wonder the software installation bails out on my 64-bit Windows 7 here. But it does work on a contemporary 32-bit version of Windows, even so the 32-bit version of Windows Home Server 2007. Now, there's no distinct differentiation between drivers and application packages. There's just one package of Netgear Storage Central Manager utility which installs both the management program and the drivers. And for the latter, I would have raised more than one question mark as a consumer back then had I been buying the product and received those warnings about non-signed Windows drivers. Of course, one might slip through with this in 2005 when the product was new, but even the latest available version from 2009 still exposes this issue. Once installed, I get the option to perform an online update, though as the product was pulled off the market in 2010, this yields an error. However, it's still possible to apply a firmware update, as the latest release 4.23 is still available from Netgear's support website. It took a mere 5 minutes to update the firmware, after which the SC101 was rebooted. As mentioned, SC101 doesn't need any configuration, it all depends on having DHCP configured on your local area network. And that one is crucial, as we will see later on, as firstly, there's no way to configure static IP addresses, and secondly, you'll need an IP address not only for each hard drive physically installed to the SC101, but yet another one for each logical drive you're about to create.
Wait a second.
Let's start by creating a first logical volume. I give it the name of test1 and assign an overall capacity of 25 GB. Now, you could set the password to protect the drive, but I'm skipping that one. Additional options to configure are the share property, which means that the logical volume could be used by multiple client machines. Plus, there's the option of creating a mirror copy, so as in to have two physical drives behind. And this is where I noticed that my SC101 did only show me one single hard drive, although I installed two drives into it. Later on I had looked into this again and found it to be a loose power connection. After reseating the power connector on the second hard drive, Storage Central Manager would report two hard drives found in the network. Meanwhile, my first created logical volume, at this point a non-mirrored one, would show up as drive E in Windows Explorer. And as you can see, it looks like an ordinary hard drive that even so shows up in Device Manager. The only notable difference is the reported file system, which doesn't say FAT32 or NTFS, but dataflow SFSZ. Now that's interesting, as obviously Netgear didn't just license the CSON technology by Cetra, but there was also SON file system coming from dataflow. It's very likely though that the SFSZ was a modified version made specifically to be used with the SC101. What makes this really obscure is the fact that SC101 only ever was compatible to the Windows platform. That's odd, as dataflow's SFS was said to be compatible for Windows, Mac and Unix Linux systems even 20 years ago. But as you can guess, SC101 never got out from the Windows world, despite Netgear unofficially promising that they will be adding Linux and Mac support eventually. At least in 2007, Cetra announced that they would support Mac clients for their CSON technology, though apparently that didn't manifest itself into the SC101T, which added a 1 gigabit Ethernet port and SATA disk support. So in the end, the Storage Central product line remained a Windows-only appliance. Meanwhile, I was adding a second logical volume of 50 GB in size. And remember what I said earlier on about SC101 consuming many IP addresses. Each logical volume will consume an additional IP address, as you can see here. And this gets even worse when expanding the capacity of the logical volume. Let's take my test1 volume I created before and add some additional 10 GB in capacity. After I've done so, it would appear with the remark of being spanned, which means nothing more than there is now at least 2 non-contiguous partitions making up that logical drive.
But it still consumes one IP address, does it?
That's not what it looks like under the hood. Netgear provides for the cscan.exe utility, and when running it with the list all command, it will reveal all logical drives. And see here how the spanned logical drive looks like, consisting of the first allocated 25 GB capacity and then the added 10 GB capacity, each of which consuming one IP address each. Notably, one IP address each in addition to all physical drive IP addresses which were there already in the first place. Now, as mentioned, these logical volumes would deeply integrate with the operating system and show themselves as real hard drives and not as network shares. This means you can do pretty much anything with them as with any ordinary hard drive. At the example of Windows Home Server, it means you could just add the CSAN logical volume to the Windows Home Server storage pool. You can even reformat any logical volume from dataflow SFSZ to NTFS if you wanted to. The only catch is, once reformatted to NTFS, you can't share that volume with any other Windows machine. But how to get back to the dataflow SFSZ file system then? The format dialog doesn't offer it as an option, and neither does the format command on the CLI. At least the most recent version of the Storage Central software offers some CLI utilities, one of which being the mkfs_fss.exe, which is obviously intended to format the drive with the SAN file system. However, while Netgear's revised troubleshooting guide makes no mention of the tool, the actual command line help isn't of much use either. One might think, given this information here, it should be easy to direct it to format the logical volume, but neither does it work using the drive letter convention nor the full volume path. I eventually tried as well the path designation as retrieved from the Windows Management Instrumentation console, and while it seemed to do something, at least implied by the artificial pause, the only notable effect was that the drive became inaccessible thereafter. I could eventually regain access by disconnecting and reconnecting the drive, though as we see here, the file I placed in there remained there, so the volume wasn't actually reformatted. What makes matters worse is the overall unreliable software stability. When reading about the SC101, I couldn't believe at first that the product testimonials on Amazon were so harsh, not to say it was testified downright an awful product. Although quite some complaints seem to be on the wrong expectation side as to where consumers expected it to be more like a NAS, where in fact it's an entirely different technology, other complaints cannot simply done away with. There is claims of sudden data loss, broken mirrors, disappearing or inaccessible drives, and bad performance. And I can indeed confirm this as it happened to me as well. Like here, when the drives would simply not reconnect upon system reboot, and even the Storage Central utility would fail to somehow locate the SC101. Now this speaks enough about software quality already, as the cscan.exe CLI utility seems to not have any issues in at least detecting the microSAN and the logical volumes. But even so, the troubleshooting guide recommends you to follow certain steps by means of the ut_full.exe utility, which is long gone from Netgear's FTP site, but thankfully still retrievable via archive.org, and it turns out that this one doesn't play well with the latest firmware release. While it seems to detect the SC101, it does not detect any logical volumes, where the cscan still does. Now that's a problem, as cscan doesn't provide for the troubleshooting commands to fix the issues, where ut_full does provide the commands, but the tool is just broken. So let's look into the overly bad performance. Of course, one should not expect any wonders whatsoever from those contemporary ATA 6 Ultra 100 hard drives, which should get close to a transfer rate of 100 MB per second. So given the 100 megabits network interface, those hard drives can easily saturate the load, as 100 megabits equates to a theoretical maximum of 12.5 megabytes per second. And it would maybe not have been that big of a problem if the SC101 held at least that promise. But in reality, performance was a lot worse than that, reaching around 4.82 megabytes for random reads and as low as 2.26 megabytes per second for random seek and rewrites. But it gets even worse, as this was the stats for a non-mirrored volume. Repeating the same benchmark on a mirror drive, I seemed to get a slightly higher read rate at 5.3 megabytes per second, but the writes went down to a meager 1.5 megabytes per second. So why that huge performance difference when using mirroring? Given the throughput characteristics of the ATA6 drives, having a RAID 1 drive mirroring shouldn't have that big of an impact. But the thing is, this ain't RAID 1. Neither does the SC101 have a built-in RAID controller, nor does it implement the mirroring itself. No sir, the mirroring is done by the client operating system. Remember again how I pointed out the many IP addresses used for each physical hard drive and each logical volume. Let's check out this mirrored volume, which as well exposes two different IP addresses. Now I'm pushing over a file onto this mirror volume. It's only 28 megabytes in size, but already when capturing the traffic in Wireshark, we see that the client effectively talks to both IP addresses. And when summarizing the traffic transmitted over the wire, it becomes clear that the client is using two distinct unicast connections, one per each IP address. So not only had the client to transmit a total of 56 megabytes, but the SC101 had to accept two incoming streams of data as well, 28 megabytes worth each, to place a copy of that file onto each of the mirror volumes. Now, Cetera was not shy to take a cost comparison on their website, stating that their solution is the most viable from a cost point of view. When compared to other competing solutions, it has its merits, as it allows you to build a very simple and cheap storage box, whereas all the heavy lifting for the mirroring is done by the client. I see the point of sparing the RAID mirroring out of the box, though that was in my opinion bad for several reasons. Firstly, if the client made something wrong, you would hypothetically end up with data not being properly mirrored on the SC101. And according to user feedbacks, this happened more often than not. Hence an indication for a badly implemented software. Secondly, putting only a 100 megabits interface, which by necessity was NetGear's oversight and not Cetra's fault, limited the attainable bandwidth. But even so, it was maybe not the best idea to send the data over the wire twice. It will probably not be as worse for a wired home network with only one or two computers, but the effect would already lead to overall saturation on the Wi-Fi network and become more of a bottleneck when thinking of contemporary 54 megabits or even 11 megabits Wi-Fi networks.
But what about Windows Linux?
As mentioned, neither Linux or macOS ever received treatment by Netgear. During Google Summer of Code 2007, Ian Wade wrote an open source driver for the SC101 leveraging the network block device NBD kernel module. So I went to install Debian 4.0, for which I first had to create the install DVD images from Jigdo. Once installed, adding build essential is enough to compile the source code. It doesn't use configure, so it's a pretty straightforward make and make install two-liner. Now, you won't get any fancy GUI like on Windows, so there's no way to create or modify the logical volumes for Linux. You still need a running Windows system side by side. At least you get the UT command, which behaves similar to the cscan command on Windows, listing all available logical volumes. It provides an attach command in order to map the volume as an NBD device. At first, this would fail with a file not found error, as I didn't have the NBD kernel module loaded, though mobprobe sorts that right away. Of course, there's no support for the dataflow SAN file system, so that's a dead end. But you can of course create a new file system on the map network block device and mount it as usual. After all, Linux also has file system drivers for FAT32 and NTFS. So, what if any logical volumes had been formatted using FAT32 or NTFS? Could the drive be shared with Linux? Apparently not, because there's some level of incompatibility. While reformatting a volume in Windows is possible, there's some mismatch with the underlying partitioning, or better said, the supposedly reported disk geometry. On Debian 4.0, the Windows-created partition looks correct in size and geometry, using 512-byte sectors reporting an overall 4 GB. Still, the partition can't be mounted, reporting a bad superblock problem. And this holds true as well for NTFS partitions. Apparently, the original code won't compile on a modern Linux distro, but the SC101 NBD driver saw several forks on GitHub over the years, with the most recent one being updated just in 2023. So I gave it a shot on Ubuntu Desktop 2404. Looking at the partition table on Ubuntu reveals some more oddities, as here the network block device is reported with a 4K sector size. This leads to the weird situation of the Windows-created FAT32 partition being reported 8 times as big, 32 GB, even though the block device itself reports its maximum size correctly as being 4 GB. I can of course remove and recreate the partition, which then ends up with the correct 4 GB size reported on Ubuntu, but because of the sector size error, the partition will then show up again on Windows 8 times smaller, essentially 512 MB. What furtherly doesn't work is the volume mirroring. While on Windows this somehow works behind the scenes automatically, that's definitely not the case on Linux. Even so, you get to see both the primary and the mirror volumes via the UT command. You can only map one single unit per NBD device. Having said that, if you wanted to have a mirroring in place, you would need to use mdadmin to create the mirror on top of the NBD devices in order to mimic the same behavior as we had seen before on Windows. And of course, with the same result of wasting resources because of duplicated writes transmitted over the network. And finally, losing some words about the performance on Linux. It's no surprise that my benchmark number reveals similar results as seen before on Windows, so there's definitely no prize to win here. After all, from an engineering and geekness factor point of view, I can totally see the magic of Microsoft technology and what NetGear etc. wanted to achieve here. Looking at those user testimonials, however, I totally see the reason for all the complaints. Stability and software quality was bad, performance was subpar, there was no cross-platform support, and it really feels like a product that was set to mature at the customer. And the problem is, it probably didn't mature well enough, so it was ultimately pulled off the market. Maybe not a surprise, as obviously the SoHo market simply demanded for NAS products. What surprises me then though is that the Storage Central still survived an overall 5 years. There's no official sales figures, but only indications from at least Cetra's own press releases claiming at one point to have an installed base of 100,000 devices and at some later point 300,000 units. In my previous video about Windows Home Server, I mentioned that market research for 2012 indicated a potential for around 4 to 5% of all US American households being a target for NAS and home server products. That's roughly 4.5 million households. Putting Cetra's claimed installed base of 300,000 units into that perspective is actually not that bad. Of course, it's not said this was all Netgear units, as Cetra had announced partnerships with other suppliers, even German-based IT supplier Transtech AG. In the end, the geekness factor set aside, the Storage Central in my opinion is a perfect example of a nice idea carried out very badly. Or what do you think about it? Let me know in the comments below. I'm the Vintage Collector and this was my story for today. Thanks for watching and see you again next Sunday.